In this lesson, we're going to talk about systems of linear equations where we have 3 equations and 3 unknowns. At this point, I expect everyone is familiar with solving systems of equations with 2 unknowns, and mostly through the processes of elimination or substitution. And in this video, what we're going to do is we're going to apply those 2 methods to solving systems of 3 equations with 3 unknowns. And also we are going to talk about the circumstances where you have an infinite number of solutions, one particular solution, or no solution at all. To start, let's consider the system of 3 equations that we have here on the screen, and we're going to use the method of elimination. I'm going to start by labeling my equations. I'm going to start with equation 1, equation 2, and equation 3. And what I'm going to do is I'm going to select these equations by pairs. So for example, I'm going to work with equation 1 and equation 2 first, and later I will work with equation 2 and equation 3 separately. Now, looking at equation 1 and equation 2, I notice that z has the same coefficient but with different sign value. So what I can do is I can start by adding equation 1 and equation 2 to eliminate the variable z. When I do that, I get as a result an equation in the other 2 variables x and y. Now I'm going to do the same with equation 2 and equation 3. So equation 2 and equation 3. And I see that z has the exact same coefficient with same sign. So what I want to do is eliminate it by taking the difference. And what we get is another equation in x and y. Now, what we have now is a system with 2 equations and 2 unknowns that we can solve by the usual methods. So what I'm going to do is I'm going to use elimination again, and this time I'm going to label this equation. It's going to be equation 4, and this one is equation 5. What I want to do now is equation 5 plus 3 times equation 4. So I'm going to write my equations right here. Now that we have x, we can use equation 4 to write an expression for y. So from equation 4, y is equal to x plus 4. So if we substitute the value that we found for x, lastly, we want to take either equation 1, 2, or 3 to solve for z. And so I'm going to take equation 2. So from equation 2, I'm going to solve for z. So z is equal to minus 1. Let's do a second example, and this time we're going to solve this one by substitution. In substitution, similar to what we did before, you want to give a name to each of the equations. So I'm labeling them from numbers 1 to 3. And what you will want to do is you want to identify one variable as well, and you want to be able to substitute that variable into the other 2 equations. For example, I'm going to start with equation 2, and I identify that it's going to be very easy for me to solve for y. So doing that, y is equal to minus 2x minus 3z. And what I want to do now is I want to create 2 new equations by substituting y into equation 1 and into equation 3. Now I'm going to do the same into equation 3. Now that I have these 2 equations, now I'm going to do another substitution. I'm going to label this equation number 3, and this is going to be equation number 4. So from number 3, I want to solve for z, for example. And what I want to do is substitute that into equation number 5. And we found that x is equal to 1. Now that we have the value of x, we can go back into the expressions for the variables z and y that we had before to find the corresponding values of z and y. And we find that the solution of this system is 1, 4, and -2. Now for our last example, I want to revisit the solutions of the previous two systems. And what I want to do in here is to show you how to solve these systems with the calculator. I know that most of you will have a TI-84 and others will have a Casio calculator. So I'm going to show you a capture of how to solve these systems of equations in each of the calculators. So we're going to designate the left system for Casio and the right system for TI-84. So please just focus your attention on whichever calculator you own.